Okay, so let me see here. Question number one. Let's see, car A. So we have car A, and that's, let's see, starts at the origin, so it starts at 1 point, then it's going this way with time at 0 seconds, obviously. This thing's going at 15 meters per second. And then you have car B, okay, car B. And this one starts at the same origin, so it starts here where time is 0. And then let's see, it starts from there, but it doesn't start till 10 seconds later. So it's going to leave here, but not till after 10 seconds. And travels, this one's traveling at 20 meters per second. Okay, so the first question is, how far from the origin is car A when car B starts to move? So we know car B starts to move after 10 seconds, right? So basically we're saying, well, how far is car A going to be in 10 seconds? So car A in 10 seconds, how far will it be? Okay. And the way you figure that out is you say 15 meters per second, right? And want to know how far it's going to get in 10 seconds, right? So you cancel out the seconds. The way you do that is you just multiply it by 10 seconds. 10 seconds over 1. And by doing it this way, you can cross out, this is seconds here, you can cross out common units. And then you're left with 15 times 10, right? So 15 times 10 is 150. And you're left with meters. So in 10 seconds, car A is going to go 150 meters. And it makes sense, right? Because in 1 second, it's going to go 15 meters. In 2 seconds, it's going to go 30. And so on and so on and so on, until eventually it's going to get to 150 meters per second. That's one. Okay, now we are on the second part of the question, which says how long has car A been traveling when it is passed by car B? So basically, when do they get to have they traveled the same amount? So we know that car A, right? Car A is traveling at, what did we say? 15 meters per second. Okay, and car B is traveling at 20 meters per second. And we basically want to know, okay, well, how much time is going to pass before they're at the same distance? So we know that car A is going to start at a certain time, which is the starting point. That starts at that time, right? And then we have car B, and what do we say car B is? Minus, right? Yeah. So car B starts 10 seconds later. So car B is going to start 10 seconds later after this one. So B is t minus 10. So by doing this, we could say, okay, well, when is this one 15 meters per second? We'll just basically say 15 t. When is that going to be equal to this one, which is 20 times t minus 10? So now you just distribute 15t equals 20t minus 200, right? And then you got to just isolate the terms. So subtract 20t, subtract 20t. And now you're left with, what's that, negative 5t equals negative 200. Now just isolate the t. Divide by negative 5, divide by negative 5. You're left with t equals negative turned to a positive. What does that equal? Is this right? 40? for 40. Yeah. So t equals 40 seconds. So that's the amount of time that goes by when their equal distance is 40 seconds. Okay. So what the heck was the question again? How long has car A been traveling when car B passes it? Oh, that's the answer. It's 40 seconds. And you could go and proof it by saying in 40 seconds, how long does car A go? 40 times 15 is what? Where's my calculator? Calculator. 40 times the 15 meters per second. That would have gone 600, right? And then this one does it 10 seconds later, so it's 40 minus 10, which is 30. 30 times at 20 miles an hour, and that's 600. That's the proof. So that's the answer to number 2, 40 seconds. Okay, and then we got what we got? C. What's this say? How far apart are the two cars after the total time of 60 seconds has elapsed? All right, fine. So A is 15 meters per second, and B is 20 meters per second. So after 60 seconds, so 60 seconds, 15 times 60. Clearly can't do simple math. 15 times 60. This one's going to be 900 meters. And then this one is starting 10 seconds later, right? So it's not 60. We're going to multiply it. It's only going to go for 50 seconds. So that means that we're going to have 60 times 20. Well, no, I'm sorry. 50 times 20. That's 1,000. So after 60 minutes, this one would have traveled 900. After 60 minutes, it would have waited 10 seconds, and then it would have gone for 50 seconds. Traveled 1,000. So the distance between the two is 1,000 minus 900, which is 1,000 meters. Okay, so the next one, I want you to graph a plot for the first 60 seconds. So here, we're going to make this little line here, and it wants 60 seconds. Let's just do 10-second intervals. So this is t is on this axis. 0, right? 10, 20, 30, 40, 50, 60, 70. Actually, no. Let's make it let's make it 5. We'll make it 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. That's that axis. And then we need, and that's time. And then we need the distance here, and we got to go up to 1,000. Let's do, should we do 150? We'll do 50s. So 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, 650, 700, 750, 800, 850, 900, 950. The thousands up at the tippity top. But I probably just screwed you because this didn't look like it had that many. 1, 2, 3, 4, 5, 6, 7, 8, 9. That graph paper is really killing you. I don't know why it's so small. Hold on, I'll redo it with a different size graph. Okay, so apparently your thing's only 11 by 11, which is stupid, but whatever. We'll do it that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Makes it much harder or easier, depending on how you look at it, to graph this. Once again, this is t, and we want to go from 0 to 60. So this is 0. And then we'll just go 1, 2, 3, 4, 5, 6. We'll just do it that way. So this is 60. So this is 10, 20, 30, 40, 50, 60. And then we'll just go in hundreds. So we'll say this is 100, 200, and this is distance. 300, 400, 500, 600, 700, 800, 900, and that's 1,000. All right, so hopefully you can see that. Let's graph now. So we have car A. Car A is going at 0 seconds. Starts moving at 15 meters per second. So in 10 seconds, right? How far does it go? Well, 10 times 150 is 150. So this is the first one, goes there. After 20 seconds, it's going 300. And then after 30, and I'm doing that by 20 times 15. And then 30 times 15 is what? My calculator again. 30 times 15 is 450. So 30, and then it's 450. And you'll see it's going to be linear. And then 40 seconds, 40 times 15. 40 times 15 is 600. Yeah. You can get a graph, and you can just, or a straight edge. Do a straight edge, and this is going to be what it's going to look like. Right. So that's A. This is car A. And then car B is, so it doesn't start till 10 seconds. So here's car B, and it goes 20 per every second. So in one more second, I'm sorry, in 10 more seconds, because 10 to 20 is 10 more seconds, it's going to go 10 times 20 is 200, right? So it's going to go right here. That's 20 and 200. And then in another 10 seconds, that would be 20 more seconds. Right, from here to here is 20 more seconds. So 20 times 20 is 400. It's going to go right here, which is 400. Right, and then we go to now the 40 second mark. So it's actually only been going for 30 seconds. So 30 times 20 is 600. Go bring this up. You're going to go to 600. And who wouldn't you know it? Look at that. There's our graphical proof of what we've already proved, where the intersection is. The intersection point for these two is at 600. So that's the next question. Yeah, and so to answer E, that's the answer right there. This is where the displacement occurs. That is when car B, which is here, gets in front of car A. And that's at 600 meters or 40 seconds.